Hey guys, welcome to this video. In this video, we will create a wellness assistant chatbot which will help us to build a workout plan, nutrition guidance, and anything regarding wellness. So let's give it a try. Ask a question before giving a plan. So we need to answer no injuries, body weight exercises, no equipment, full body exercises, anything. I think okay, all of this are here. So it will give us a list of exercises. Okay, so here are the exercises list. So we can simply click on the exercises. It will give a description, targeted muscles, and a video. So you can see the video and follow that exercise. So we are not creating that video through LLM. I will show you how we are doing that in the code. So okay, let's get started. Okay, so let's get started. First we need to set up our project. So I am using UV. You can use any if you want, like by paper or something, but I'm using UV in this project. So let's create a project name wellness chatbot. Okay, so let's get inside that. We need to install the dependencies. We are installing fast API. Basically, fast API is a Python web framework. It's the framework we use to build our API endpoints. LangChain toolkit for building LLM apps. It's what we use for the tool decorator and message helpers. LangChain OpenAI to call the OpenAI APIs. LangGraph framework for building stateful AI engine as a graph. It is what we use to run our like summarize tags, agent, tool flow, etc. LangSmith, basically debugging and monitoring tool for LLM apps. It's basically what we will use to see what our agent is doing behind the scenes. Pinecone is simple a vector database. Python.env is a env variable loader, and UVCon is like to load the server. So let's install these. Okay, so the installation is completed. We need to activate that project basically. So we can activate. Okay, so let's open this. Okay, so we need to create one file for chat services. We need our env file as well. So we need few things like OpenAI API key, Pinecone API key, and these types of things. So let's set up that. We can just simply go to Pinecone API, pinecone.io. You need to log in that. I already created that project, but if you want you can create that. Simply go and click on that create index. My limit is already full, so I can delete one for you guys. Chat wellness, just delete that. Okay, so let's create that index. You can name it whatever you want. Let's simply say wellness bot. Okay, wellness index is fine. So wellness index, use embedding 3 small because it's enough for our testing. We can use dimension of 1536. I'm using AWS cloud provider, serverless region. This you can change if you want, but I will recommend use these ones right now. So simply create that index. Okay, so the index are created, and okay, so it will take few seconds to up and it's live. We need LangSmith as well. Here is the LangSmith. In the LangSmith it is same. You can just click on that. I already created that project. You can create by clicking the plus button, name it wellness and on anything you want. Just create that application from here, and it will give you the instruction guide as well. Just go on the settings, create the API key by clicking here. Just create the API key from here. Okay, so go back to here. We have okay, so it's our wellness. So I'm just copying all the keys at one time. and pasting it here. So okay, so I will revoke all the keys after this video. So I will OpenAI API key is here, Pinecone API key is here, LangSmith tracing, it will automatically trace if you add it in the env and install the dependencies. So just replace it with your API keys. So let's go on the chat.py file. We need to import these things. I will let you know what each of these are doing. We need to call that load env function basically to load the variables from the env file. Then we need to add the system prompt as well. So I'm just pasting that, it's too long. Basically this is the personality and rules, you can say, like tags given to the AI every time. In simple terms, it says basically you are only a fitness assistant, nothing else. Before giving advice, always fetch the user's profile first. Ask about injuries, equipments, muscles before giving a plan. When recommend exercise, only pick from a fetch list and rep exercise name is in a special variable. So we will get the JSON format, and when it will recommend exercise, so it will give us exercise ID and name. I will let you know why I keep it here. So yeah, that's it. On one more thing, it is showing that never reveal. It's powered by OpenAI ChatGPT, because we don't need to give that information to that users. So okay, so we need to create an agent state as well here. So this is the agent state. Simply basically it's a small data structure that tracks what the API is, what the basically AI is carrying around as it works. It has like messages, the conversation so far, summary, compressed summary of older parts of the conversation, so it don't forget things once the chat gets long. Okay, so we need to provide a agent note as well. So our agent note function is here. So I'm just, for to saving just the time, I am like pasting all the stuffs. So agent node, basically this is the brain step. Builds the system prompt, add the summary if one exists, sends the full conversation to the LLM, returns the AI reply. That's it. Now we need to add a summarize node, which basically summarize our messages, like the older messages, and delete the new messages. So this is the summarize node function. Basically it keeps the conversation from like growing forever. In simple terms, if there are 10 or fewer messages, it will do nothing. Otherwise, find a safe cutoff point, like must land on a human message. Basically when we cut the messages, like for example we have 10 messages and we are basically deleting the messages or cut off the messages, it will cut that message when the human message started. Will not like cut from the middle of the conversation, like it will not cut up the AI message, it will not cut out the tool message and these types of stuff. So it's basically a summarize node. After the summarize node, we have a build graph function. So this is the build graph. The wires, basically build graphs wires together the flow of the chatbot like a flow chart. It will start like from the summarize pattern. It will start the node, runs first, summarize node runs first, then the agent node thinks and replies or decide it needs a tool. Our agent node is this. Tool condition check, like we need to call the tool or not or something like that. We have two tools right now, like user profile and the exercise one. It's a simple check pointer, which is basically a memory saver, lets a graph remember conversation state between calls. It's simple, that build graph. So okay, so now we will create our class, which is chat service. In the chat service we need few things. We need to initialize basically a few things, which are these. Okay, so what it is doing, let me know. Self embeddings, OpenAI embeddings, we are using text embedding 3 small, so we are telling that we are using this embedding. We are simply getting the environment variable key from the Pinecone API key. Index name, it is chat learning. I think I have added that wrong here. Let me check what we have here. It's a wellness index, so you can replace it with your ones. Okay, so it's just the configuration. We are using serverless cosine 1536, and that's it. Now after this we need to create a tool basically, which basically fetch the exercises. Okay, so we are simply using tool. Uh, we define the tool by this decorator @tool. It's a plain function like get exercises. You can just simply add tool on top of the function, so which makes it tool. This is the description. From this description basically the LLM knows what this function do, and it's returning the exercises list basically. So we have less data, we have 10 exercises right now, but you can expand if you want to, like you can add 100 and 1000 exercise for LLM to respond better. So we have then get user profile. I am placing it here. So currently the purpose of get user profile I am doing here, it is because when the LLM answers the question, so I want that it will basically fetch the user's data before answering the user. Like for suppose I already created some profiles. If you are in a production application, you have these profiles in the database, you will fetch from the database, but right now I just hard coded that, so we can make a tool basically to get the profiles. I just want to clear the tools concept, so that's why I use get user profile function here, so LLM knows like which profile we are talking about. So I have created the two profiles here. Okay, now we need to save the message to the Pinecone. I am creating a function basically here to basically save the message to the Pinecone. This is the simple function. Basically we are taking the user ID, we are taking the content, and the role is basically who is replying for that message. Like AI is replying it, like the message is by AI, the message is by human, or it's a tool message, something like that. We are adding the metadata in which we are adding the user ID, content, and the role, and we are assigning the simple user ID to that. Okay, so now we have that function to add the message in the database. Now we have a function to get the message from the database. We are using vector db, which is Pinecone, you already know. So it's a simple function which basically picking up the, if you didn't give the top k, it will by default it will pick 3 questions from the database and it will show the top 3 matches. Okay, so now we need to add an inject summary marker. Basically what it is doing, it's basically telling that that message format, like the format have the our exercise ID and the name like this, because in the front end what I want to create is like when LLM replies that exercise which LLM recommended, I want to make it as a button. So I will click on that button and it will open that exercises. So if it is a plain text, it will not possible to click on that plain text and then open the specific exercise. So that's why I have created that. Okay, perfect. So then our main function is chat function. Okay, so let me create that chat function directly here. Okay, so I am copy pasting it fast just because we will save time, and to be honest it can all be done from the Claude or something else. I am for just conceptual, I am just giving like a line by line or function by function instruction. So we have that chat function. We have a thread id. Thread id is basically a unique id. I am considering thread id as a user id. In the LangGraph we pass the thread id because if you want to give the response to the same user, so it will, our messages will not merge. Like for suppose 3 users application using our application at the same time, so the messages get merged. Like if user 1 types something and user 2 gets that message, so for that we use thread id for that. We are just creating a simple array. In that array we are embedding the message name with the human message. It means that this message is belong to the human. Previous QA match, basically what it is, it's a, I try to add some RAG concept in this code. Like it will fetch the previous conversation of that specific user. Like for suppose if the relevant past conversation is in our DB for that user, so we will fetch that. So what happens in RAG pipeline, it's simple. We have some data. It can be in any format, like it can be a text format, it can be a document format, and anything. And what we do, we just chunk that database. We just split that text for suppose the 1,000 line code, and we chunk in 1,000. We make a chunk of like each 1 line, so we have 1,000 of record, and we make the embeddings of that chunks, and we save in the vector database. It's simple. So what we are doing currently is we are saving, we are getting the messages, we are converting that message in the embeddings, and embeddings are saving in our database, which is vector, which is Pinecone. So yeah, the concept of RAG is similar to that. So I want to implement something similar to RAG pipeline in this. So I have implemented that. Like if we have any user conversation, past conversation, so we can simply use that basically in our LLM. So it's simply calling that save message to Pinecone. We are defining our tools, like tools get exercises and get user profile. We have 2 tools. So when LLM runs, it will check, okay, so user ask about exercises. We have a tool of get exercise in this. Here you can see. So LLM will forcefully recommend the exercises to the user from our this array. Right now it's only 10, but you can add more exercise in the production side. Definitely, it's just an example. So yeah, we have a 10 exercises that our LLM will recommend that exercise from these 10 objects simply, and it will fetch get user profile every time. So we have a data of that user. For suppose we pass the user ID 1, so we will get the user age, user weight, unit, what is the goal type of that user. Some user wants to lose the weight, some user wants to gain the muscle, user gender, if the user is male or female, and that location. That's it. Then we are simply calling the chat in AI, and we are using this model GPT-4o mini. This is a small model and not cost like mostly, but yeah, it's a budget friendly chat model. We are setting up the temperature. What is temperature? Temperature is basically you can say the quality of the content or the creativity of the content depends on the temperature. If you reduce that, you will get like unresponsive, or you can say irrelevant messages. That's it. We are adding the limit of tokens to 500. We are binding the LLMs tool, which is simply we can show we have added in our array, and we are just invoking our LangGraph. We are passing the messages in that. In the answer, we get the messages list, so we are showing the updated message here. So yeah, so we are basically in this line, we are what we are doing, we are basically changing the response behavior, which I told you before. Here you can see we are telling the LLM that not the LLM, the response basically. So it will show us the exercises like this exercise ID and the name, something like that. Okay, so yeah, it's fine. So let's go in the main.py and let's create our router. So we need to import fast API. We need to add a pydantic model basically to just validate the response. We need to call our chat services as well, from chat import chat service. Then we need, right now I am trying to hard, okay, I think it's fine. I am defining the response here as well. This is our chat request response, this is our chat, sorry, this is our request and this is our response. Okay, so I am creating the endpoint, remove that code basically. So for the chat services I need to define that chat service here. I need to tell that this app is that fast API for that, which is okay. And I need to create one more API of, okay, hard code, sorry, I forget that. Right now I am hard coded the user to 1, so all the users will go on the user 1 here. We have 2 users. Basically the flow is like when we log in, and when any user log in, it has like each user ID, each user has their own ID. Currently we don't have a login system, so I'm just hard coding it right now. So all the user has like the one hard coded ID. And okay, so I need to create one more API for the exercise here to fetch all the exercise list here. Just get terminal, we need to close. Okay, so our project we can sync. Okay, so okay, fine. So we need to run Ubicon app.main app and reload. Okay, so it's showing that, okay, I just missed it. It's your Ubicon main app. Okay, so okay, so it's started. We can go on this URL and simply paste that. Okay, sorry, we need to open the docs as well. So we will get our exercise endpoint here. If we get this, we are simply getting all the exercises list. If we want to go to chat endpoint, you can simply chat it. You can say hey, it will respond. Okay, just wait for the response. It's calling the OpenAI API. For that, yeah, here, hello, how can I assist you on your wellness and fitness journey today? So you can send any message. For suppose I need to get exercises to, you can see, wait, oh sorry, I just misspelled it. So it's okay. Okay, based on your health assessment, it is showing that my age is 28, weight is 75, goal is lost weight. To create a personalized workout, it's basically the format which the AI gives us. Like in the front end side, our format is totally different. So right now what I want is, like, I will create basically a static folder for right now. So what it will do, it will just render our it will give our like front end simple one page application which will call our APIs. So I'm calling that here in the index.html file. So here is the index.html file. So I'm just copying and pasting here for like I will push it on the GitHub as well. Just save it and just go on the main.py. And when we go to main.py, we need to basically load that. Okay, so we need to create that router for that. Okay, so it's async def run oh sorry, it is in dash root return. We need to import that file response here. We have a file response, so we will say file response static and index.html here. Sorry for the misspelling. Okay, yeah, it's fine. Just save it. Now if we run our project without doc, it will load a beautiful UI here. Yeah, so it's our wellness assistant. Now we can message him here, hey, so it will respond. Perfect. So it's telling like the based on your health assessment, the age is 28, the weight is 75, the goal is lost weight. Now let's proceed with the questions. Like it's asked multiple questions to the user because we mentioned to our LLM in the system prompt. You can see like always ask the questions about the injuries or something before giving any advice. So we mentioned that in our system prompt, so that's why it's asking. So I can simply provide that no injuries, home workout, and okay, body weight is fine. Body weight, which muscle, we can show the full body muscle. Now it will recommend the exercises, and I'll let you know why we have added that here. What we are doing, sorry, here in the inject exercise mark. So what it is doing, it is basically convert the text into a button, beautiful UI, because of this function we are telling that the marker is our exercise, and when we have exercise ID or name, make this that button. So when we click on the squat, it will show squat, a lower body compound exercise target quads. It will show which muscles it's hitting. It will show the video. The video URL is from the code. Basically, don't assume that the LLM is creating that video as well. We just created and guided our LLM that use these exercises. Okay, so yeah, also now we will check. We have implemented most of the things in the wellness indexes. So our in the code you can see our index name is wellness index. Okay, so it's this. So we are asking the users, and it's created the index, it's giving the score. So the it is replying the content of the AI reply. So we are saving it in our database. All the messages are showing in the database. Okay, so when we go on the LangSmith, I need to check which project I add here. Okay, it's wellness. Okay, so let's go in the wellness, and it will tell all the traces basically. So when we hit that get exercises, it will tell us like, okay, so this was the latency. You can see we are getting these latency here. I think there are some issues as well in this, but let me check. Okay, so the output is this classic. Okay, so these are the JSON response output. Okay, this is the tool response basically. This is not that AI respond is here, which takes time like 6.06 second or something. These are the AI response. When we go on the production level, we can optimize this. Definitely we can use the cache strategy and these types of stuff in that. So yeah, there are multiple things. You can see we can trace the token cost as well. Like here it will show like how many dollars we are spending on that token. So yeah, so here are all the details. Here we have a docs folder, we have API ready, we have our front end ready. So I will upload this code on the GitHub as well, so you guys can try it and you can learn it, like how easy to create a chatbot. So let me know if you have any question in the comments, so I will try to reply all of that. Thank you so much. Bye.